Choosing the right medium for a sculpture is an important piece in the artistic process. Many master sculptors through the years have chosen marble as their medium. It's a finely grained, fairly soft rock that can be polished, and it refracts light in such a way that it creates a waxy surface appearance. Rick Delano has used Yule marble to create some of his pieces. It's quarried near the town of Marble, Colorado. So what geologic processes caused this pure white marble to form in the mountains of Colorado? We have to go back over 330 million years to when the land that we now call Colorado was much closer to the equator. At that time, Colorado was covered with a warm, shallow sea, inhabited by corals, brachiopods, trilobites, and cephalopods, as seen in these fossils. As these organisms died, their calcium carbonate shells sunk to the seafloor, accumulating in thick layers. Over time, these layers hardened to form limestone, which is a type of sedimentary rock. The limestone eroded and was buried for 300 million years until Earth's tectonic plates shifted and hot molten material from Earth's mantle rose toward the surface. This is called an igneous intrusion because the molten material thrusts upward, disturbing existing rock layers, and then cools to form an igneous rock like granite. In this case, the molten rock rose in a dome shape with a flat bottom, called a laccolith. As the dome formed, it tilted the limestone off to the side at about a 45-degree angle. The pressure and heat from this molten dome caused the limestone to recrystallize, forming a beautiful white marble. This is called contact metamorphism because only the limestone close to the dome morphed or changed into marble, which is a type of metamorphic rock. This shift between sedimentary, igneous, and metamorphic rock is characteristic of the rock cycle model, which is a way of explaining how rock is constantly being formed and changed over time, like all matter here on Earth. The way that rock is deposited and eroded, heated and exposed to pressure, gives it the unique characteristics that sculptors prize when selecting the appropriate medium for their work. In 2010, experts gathered at VMFA to determine what the statue of Caligula might have looked like when it was first created. They used laser scanning technology to create a computerized 3D image of the sculpture. They measured nearly 137 million points on the statue to an accuracy of about 1/10 of a millimeter. How small is 1/10 of a millimeter? Well, if you take the width of a dime and divide it 10 times, you'll have 1/10 of a millimeter. Do you think that this degree of detailed measurement could be used to make an accurate model of the original statue? Absolutely. But what if we wanted to create a scale model of the statue? A scale model is a larger or smaller version of the statue in which all of the parts are still in relative proportion to each other. The scale of the model is stated as a ratio, or a comparison of two quantities. It can be expressed in many ways. For example, a ratio of 1 to 4 can also be written as 1/4, 25/100ths, or 25%. These numbers tell us that the scale model is 1/4 the size of the actual statue. So if the model is 2 feet tall, the final sculpture will be 8 feet tall, or 4 times as tall. How did I figure that out? I set up a proportion, which is an equation stating that two ratios are equal. If 1 foot on the model equals 4 feet on the statue, then 2 feet on the model equals 8 feet on the statue. In a true proportion, the cross products are equal. I can use this information to find out more difficult measurements as well. The statue of Caligula is 203 centimeters in height. Let's assume that I want to create a model that's 1/5 the size of the actual statue. What is the height of my model? I can set up my proportion equation as shown, find the cross products, and solve for x. So the final height of my model would be 40.6 centimeters, or 1/5 the size of the actual statue. Not quite as statuesque as Caligula here in the museum. Sculptors can use scale modeling techniques to create a maquette or model early in the sculpting process that can later be copied into stone using calipers or other measuring devices. They can also use scale drawings and models to help determine the size of the marble block that they need for the final sculpture. It takes a lot of work to chisel away excess marble during the roughing in process. So the closer the original block is in size to the final dimensions of the sculpture, the better. In 2013, VMFA's Caligula statue was studied using stable isotope analysis to determine whether the head and body of the statue were created from a single block of marble and to determine what quarry the marble originated from. This seems like a daunting task, considering that this marble statue is nearly 2,000 years old. However, the marble, remember, is simply a rock. And rocks have unique geochemical signatures based on how, when, and where they formed, what minerals they contain, and how the environments interacted with them over time. So how does stable isotope analysis work? First, we need to understand what an isotope is. Isotopes are atoms of elements, like carbon, for example, that have the same number of protons but a different number of neutrons. Carbon-12, the most common form of carbon, has 6 protons and 6 neutrons, whereas one of its isotopes, carbon-13, has 6 protons and 7 neutrons. Carbon-13 is a stable isotope, meaning that it does not decay or break down over time. Using stable isotope analysis, we can find a ratio of how much carbon-13 to carbon-12 in a sample of marble from, say, Greece versus a sample of marble from Italy. And what we're going to find is that the ratio of carbon-13 to carbon-12 in the Greek marble is going to be very different from that same ratio in the Italian marble, because those marbles were created under different conditions, at different times, and in different places. By taking advantage of these unique ratios, stable isotope data can be used as a tool to identify marbles from around the world. For example, samples were taken from the Septimius Severus statue at VMFA. In this case, stable isotope analysis showed that 3 different types of marble were used in the statue. Different quarries were active at different points in history, so having this information leads us to believe that the head and torso of the statue are ancient, and portions of the arms and legs were 17th century additions. In the statue of Caligula study, researchers took small samples of marble from the statue's head and from the statue's torso. The stable isotope ratios of carbon-13 to carbon-12, as well as oxygen-18 to oxygen-16, strongly suggested that the body and head of the statue were made from the same block of marble. Also, by comparing data from the statue to a database containing stable isotope samples from marbles around the world, it was determined that the original source of the marble was most likely the Greek island of Paros. Another mystery solved with science.